Good morning, my dear students. My name is Twayna. I am currently available at the Hamlet Tuition Center, Brahmotol, Kathmandu, and the Kumudini Kunja Secondary School, Kalimati, Kathmandu. My dear students of grade 8, this is your science class, and today in science class we are going to start our new topic, new lesson, and this is lesson number 8, sound. Well, first of all, let me go to introduction of sound. Well, you pretty well know what is sound, isn't it? What I am making right now is a sound. I talk, I make sound. You talk, you make sound. Or you bang on your table, you make sound. Okay, you turn on your television makes sound. Yes, bird chirping makes sound. That is also sound, isn't it? The vehicles, they honk, that is also sound. Or even the engine of vehicle also make sound. The concert hall, in the concert hall many are playing instruments, some are singing, and the audiences are hooting. All of them are making sound. And you can see here the loudspeaker, it also makes sound. The thundering definitely makes sound. Yes, and that is the sound that makes us terrified. Okay, and the person playing a tabla, it makes sound. A person playing a flute makes sound. Person playing a sitar makes sound. See, we are surrounded by sound, isn't it? Everywhere in our surrounding there are at least some sort of sources or objects that make sound. Okay, right now also you can make a list of the things that are making sound. Yes, now what is sound? Well, I have repeatedly told you several times that the universe, the whole world, is made up of two types of things. Only two types of things. One is matter, another is energy. Okay, matter you can see and you can weigh out. Okay, you can take weight of matter. Matter has mass, but energy, you cannot take weight of an energy. Energy does not occupy any space. It does not contain any matter. Okay, energy is just something that makes us able to do something. Okay, energy is that something that makes us able to do something. Okay, now in this case sound, in the case of sound, sound is also an energy. Okay, sound is also an energy, and there are several forms of energy, and among them sound is the form of energy which makes us able to hear the things. So sound gives us sensation of hearing. If there are no sound energy, then you cannot hear anything. If there are no sound energy, then you cannot hear anything. Okay, like the person playing flute, or the person playing sitar, yes, the person playing tabla, okay, or a bird chirping, vehicles honking, the singer performing in concert, okay, or someone playing loudspeaker, or the thundering. All of them all of them produce sound energy, and because of that energy you can hear them. Okay, right now as well I am producing sound energy. That is why you are able to hear me. Okay, if I speak without any sound, then, well, how will you hear me? There is no way that you can hear me. Okay, next, it is produced due to vibration of membrane or molecule. Well, sound is produced when molecules vibrate. Or you can experiment one thing. Do it right now. Speak something and put your hand or your finger on the bottom of your neck. Put your hand or your finger at the bottom of the neck, like at this position. Put your hand at your neck and then speak something. Okay, did you feel vibration or not? Yes, you feel the vibration. Of course you will feel the vibration. Okay, or when you are playing drum, if in school we could have done that, but now it's not possible. But while doing march past in morning assembly, you play drum, yes? And while you play drum, closely observe the membrane of drum. What you will see, the drums vibrate. The membrane of drum vibrates. Okay. Similarly, you can do the same experiment on any steel utensils at your home. Yes, if you hit the steel utensil with a stick or something, then you can see the vibration of the utensil, of the membrane. Okay, so sound is produced due to vibration. Now in case of animals and birds, their vocal cord produce sound, yes, and during that process the vocal cord vibrates. Okay, vocal cord vibrates, that produces the sound. You have just felt that in your neck, isn't it? And in case of vehicles honking, well, the vehicles also have a speaker like this. Yes, they also have speaker, and when a speaker is playing, if you touch on the surface of speaker, you can feel the vibration, or even you can see the vibration. Okay, or the engine of vehicle also makes sound, isn't it? And that sound is made by vibration of the parts of engine. Okay, and in case of a flute does not have any membrane. Then what does vibrate? Vibration of what makes sound in a flute? Well, it is vibration of air molecules inside the flute. Okay, the flute has air molecules inside it, isn't it? And by blowing into the flute from one side, you set up vibration in the air inside the flute. Okay, and by blocking several pores in combination, usually by letting only one pore to open, you can produce different scales of sound. You can produce different sound, okay, by opening a particular pore. Okay, similarly, in case of sitar, what vibrates here? You know it very well. The string vibrates. You can see the string vibrating. If you do not have sitar, yes, of course, it is exotic, yes, but you might have seen guitar. Guitar is quite common. Okay, while playing guitar, while an artist is playing guitar, you observe carefully, and you will see that the string of guitar, they are vibrating. Okay, that vibration produces the sound. If you touch the screen, then the vibration stops and sound stops as well. Okay, now let's go to next point. I hope you understand that point. Okay, second one, it transmits through, no, third one, it transmits through mechanical wave. Now understand the term wave. The term wave is new to you. Okay, wave is path of energy. Wave is path of energy through which energy transmits. The path through which energy transmits is called wave. And there are two types of wave. One is called mechanical wave, another is called electromagnetic wave. In detail you will study in grade 9. Okay, one is called mechanical wave, another is called electromagnetic wave. Now those wave which can travel, or those energy which can travel even in vacuum or in space, they are called electromagnetic wave. And those wave which cannot travel in vacuum, which need material medium to travel, is called mechanical wave. Okay, so mechanical wave is like you pass the book in your hand to your friend. An electromagnetic wave, like you throw the book to your friend. Okay, while passing the book to your friend, one by one, you will need your friends. You will need the help of your friends, isn't it? But while throwing the book, you definitely don't need the help of anyone else. Okay, just like that. Okay, so the sun actually produces both light energy and sound energy. The sun produces both light energy and sound energy. But does sound from sun reaches the earth? No, definitely no. Only light and heat reaches the earth, but sound does not reaches the earth, because light and heat form electromagnetic wave, whereas sound form mechanical wave. So light and heat can travel through space, but sound cannot travel through space. Okay, you need air for sound to travel. Okay, or you need some wire or solid or liquid, and you need any material medium for sound to transmit. Without material medium, sound does not transmit. Okay, have you ever wondered what would happen if we were taking this class on the moon? Well, moon does not have an atmosphere, so whatever I am speaking, you won't be able to hear. Whatever I speak, you won't be able to hear. You will be able to see my lips moving. You will be able to see the lip sync, okay, movement of lips, okay, the sign languages, but you will not hear a sound. Understood? That's why when astronauts go to space or moon, they need to talk with the help of walkie-talkie. Even they are face to face, they need to use walkie-talkie or transmitter to talk. Okay, and that transmitter is usually fixed inside their spacesuit helmet. Okay, so it transmits through mechanical wave. I hope you understand it. It cannot transmit in vacuum. It needs material medium to transmit. And next one, it can produce both longitudinal wave and transverse wave depending on medium. Well, longitudinal wave is something like this. See the cursor of my mouse, see the movement of my mouse. Longitudinal movement is like this. Okay, this type of movement is called longitudinal movement. And transverse wave is the movement like this. Understood or not? Understood or not? The transverse wave is movement like this. Okay, so sound wave can produce both type of movement, both type of wave, but most commonly sound produces longitudinal wave, especially when it is traveling through gaseous medium or air. It produces longitudinal wave. It transmits like this, sound transits like this. Okay, but when it is traveling through solid and liquid, it transmits like this. Through solid and liquid, sound form transverse wave. Okay, so depending on the medium, sound can produce both longitudinal wave and transverse wave. However, the electromagnetic waves such as light and heat, they always make transverse wave. Understood this much point? Okay, if you understand this, let's go to next title, the sound wave. Okay, our next title is sound wave, and I've already told you sound wave is a mechanical wave that mostly transmits through longitudinal wave motion in air. Okay, I'm talking about in air. In water or in solid, sound travels by sound propagates by producing transverse wave, but in air it propagates by producing longitudinal wave. Now let's understand longitudinal wave first. Let us suppose let us suppose that, let me remake this. Okay, okay, I have remade the diagram. Here what you can see, suppose these are the molecules of air. Okay, these are the molecules of air, and you can see they are almost distributed with equal distance to each other, isn't it? They are almost in equal distance to each other. However, when a source of sound produces sound, when a source makes sound, then that sound is manifested as vibration. Okay, that means the membrane of source of sound vibrates. Because of that, the air molecule which is in contact to the membrane, it will move this way, like this. Yes, and when it strikes another molecule, then what happens? It will move back, it will bounce back, whereas this molecule will move forward. because of the energy it receives. Yes, and it strikes another object, okay, another molecule. Then again what happens, the molecule is the energy is transferred to another molecule, it will bounce back and this molecule will move forward. Again this energy is transferred to next molecule, so it will move and it will bounce back. Okay, here also what happens, since the fourth molecule passed energy to next molecule, the next molecule move forward, it moves backward. Okay, so this also hits another molecule, comes backward, and another molecule will move forward. Okay, it also hits another molecule, so likewise it will keep on going. So until now, see, energy has been transmitted from this point to this molecule. Okay, so after passing the energy, this molecule comes back and this molecule moves forward. Okay, it also passes energy, it comes back, it moves forward. It goes on like this. It goes on like this. Understood? Okay, so that I was talking about single note, production of single note. Like I say, that is single note, ka, single note, kha, single note. But if I say ka, ma, la, then I am sending you 3 notes. Okay, likewise when I am speaking, I am sending numerous notes, isn't it? So the process keeps on repeating. That means when the first note reaches at this point, second note already arrives and this again energizes. Yes, this again energizes. So when this molecule actually was transmitting energy to this molecule has already received energy and it has already moved to here. Okay, then it comes backward, it also comes backward. Okay, because of that this molecule, it moves forward. Yes, moves forward. At the same time this molecule also moves forward. So if this keeps on going, you can see due to transmission of 2 notes, you can see that at 2 places there are densely packed molecules, isn't it? At 2 places there are densely packed molecules, and between these 2 densely packed molecules, the molecules are freely packed or loosely packed. Are you getting me or not? Yes? Okay, similarly when this note, okay, let me release it to its original place. When the note which was here reaches here at this point, when that note reaches here, then the note which was here will reach at this point. Yes, and at the same time the speaker will release another note. Okay, in this way, see, if the speaker sends 3 notes, then you can see there are 3 places in medium where molecules are tightly arranged, where molecules are actually energized, and between these energized molecule there are molecules with low energy, de-energized molecules. Okay, so this pattern keeps on repeating. How many tones are sent by the source of sound, that many number of patterns will be there. Understood? And because of that, it will look like this. Okay, let me copy this now, Control C. Okay, now I can remove this. You understand this? Yes? Okay, you understand this? Yes? Okay, so because of repeated notes, there will be a pattern in which at certain place molecules are tightly adjusted, certain place molecules are loosely adjusted. Okay, so the position or the point where molecules are tightly arranged is called compression. Okay, the position at which molecules are tightly arranged are called compression. What is it? It is compression. And the molecules, the part of medium where the molecules are loosely arranged, it is called rarefaction. Okay, the position, the place of medium where molecules are tightly packed is called compression. Okay, and the position or place of medium where molecules are loosely packed are called rarefaction. So in short, you can indicate them as CR. Yes, C stands for compression, R stands for rarefaction. Okay, so this pattern CR, this pattern will repeat itself. Understand? Okay. Did you see it? Compression, rarefaction, compression, rarefaction, compression, rarefaction, compression, rarefaction. The wave travels like this. Okay. Now in this transmission you can see that energy has transmitted from this point, from speaker to finally this point. Okay. Energy has transmitted from here to here. That means this is the direction of transmission of energy. This is the direction of transmission of energy. Direction of transmission of energy. Energy is transmitting in this direction. And in which direction are molecules moving? Molecules are also moving in the same direction, isn't it? These molecules, they vibrate like this. Like this. Yes? So this direction of transmission of energy and direction of vibration are the same. Okay? Such kind of wave is called longitudinal wave. Okay, see, longitudinal wave. The definition of longitudinal wave: the wave motion in which particles vibrate in the same direction as the energy transmission is called longitudinal wave. It requires material medium to transmit, as it requires vibration of molecules. So this kind of wave motion cannot transmit through space or vacuum. You understand the second point or not? So for transmission in this way, it requires molecules. In this way, energy is transmitted by the vibration of molecules. Okay, and since in space there are no molecules, energy will not transmit through longitudinal wave in space. Okay, so for transmission of longitudinal wave, it requires vibration of molecules, and this kind of wave cannot transmit through space or vacuum, and it has relatively slow speed because it has to pass out the energy to adjacent molecules. Okay, next it consists of compression and rarefaction. That I have already told you. At the point of medium where particles are tightly adjusted, it is called compression, and the point of medium where particles are loosely adjusted, loosely packed, that point is called rarefaction. Understood? Okay, see, it consists of compression and rarefaction. The part of medium at which molecules are densely packed is called compression. Particles at high energy state in compression, whereas the part of medium at which molecules are loosely packed is called rarefaction, and particles are at low energy state in rarefaction. Any confusion up here? Okay, if there is no confusion, okay, I hope you are entertained in today's class. You understood the things clearly. Okay, today we are going to do only this much. In our next class, we are going to discuss about the properties of wave. Okay, properties of sound wave, and then we'll have to do some numericals as well. Okay, until today, if you need revision, because the words, the terms we encountered today are new terms to you. They are new to you. Okay, you have not heard about these terms before, like wave, longitudinal wave, compression, rarefaction, yes, and then mechanical wave. These are some of the new terms you encountered today. And if I'm going to continue the class, actually I still have time. Yes, it has only been 25 minutes. I still have time. But if I am to continue the class, even more of new terms are going to strike you. Okay, and that is not good for understanding. Yes, did I say right? Okay, so today we are going to only this much. Okay, I hope you will play this video twice or thrice until you understand it completely. Okay, see you until our next class. Thank you, class.